Hello, good evening to everyone in our listening audience. My name is Angela Burnett, and I will be your host for this evening's webinar. I'd like to start us off with a reading. All around the world, we see that human society is finally adapted to what might be expected in a few generations. We are clever optimizers, building for what we can expect to happen in our lifetimes, but never wasting resources on something that would occur less frequently. The trouble is that the past is no longer a good guide to the future. Hurricanes are fueled by the evaporation of seawater, and the warmer water becomes, the faster it can evaporate. We have known for 30 years that increasing atmospheric carbon dioxide increases the speed limit of hurricanes, and it does not come as a surprise that we keep breaking hurricane records. With peak sustained winds of 185 miles per hour, Hurricane Irma held the record as the second most intense hurricane ever recorded in the Atlantic and the most intense on record outside the Caribbean Sea. It was the most intense hurricane ever to have affected the Lesser Antilles. Sadly, we expect to see records like these broken again over coming decades. My group at MIT has spent many years researching the physics of hurricanes and learning how to apply advanced understanding to the estimation of hurricane risk. We estimate that in the year 1990, the probability of encountering a hurricane of Irma's magnitude or greater within about 200 miles of Barbuda was only about 1 in 800 in any particular year. Whereas by 2017, the annual probability had increased to 1 in 180. Absent any measures to curtail further greenhouse gas emissions, we estimate that by 2090, that probability will have increased to 1 in 60 in any particular year. When events like Irma become far more frequent, the results will be devastating, until slowly society adapts to the new reality. You've just heard an excerpt from the foreword to the Irma Diaries, foreword written by Kerry Emanuel, who is a world-renowned meteorologist and professor of atmospheric science at MIT, where he also co-directs the Lorenz Center dedicated to learning about climate. He specializes in tropical cyclones with a focus on hurricane physics. I want to pair that with a very brief excerpt from the afterword to the Irma Diaries, written by our very own Professor Michael Taylor, who is a senior lecturer and professor in the Department of Physics at the University of the West Indies Mona campus. He also is a director of the Climate Studies Group at Mona. His research interests center around enhancing an understanding of the Caribbean-specific impacts of climate change. And he says, in a real sense, Irma portends the future challenge of climate change for the Caribbean region. That is the challenge of living in a new era, likely consistently marked by climatic events only rarely seen to date, or by climatic events that have never been experienced before. It is the challenge of living with the unprecedented. Very pleasant good evening to everyone joining us. For those who missed the very beginning, my name is Angela Burnett, and I will be your host for this evening's session, which is part of the 2021 Domus webinar series exploring the economic cost of natural disasters, looking at preventative measures to save you. This evening, you will have the benefit of hearing from 5 panelists as we explore different aspects of this topic. You will hear about how hurricane risk is increasing. You'll also actually hear personal experiences of surviving a Category 5 hurricane from Hurricane Irma right here in our region. We will explore design considerations for new and existing buildings so you can appreciate how to make buildings more resilient to these types of extreme events. We will also explore national quality infrastructure right here in St. Lucia's context. We'll also look at the cost aspect of resilience, which is, of course, a very important factor for all of us. And we'll dig deeper down into the matter of how exactly we go about reducing hurricane and flood risk. Very practical advice for you as a homeowner, future homeowner, current or future business owner, so that you can really leave here this evening with a better appreciation of how risk is changing for us here in the Caribbean, and what are some practical steps that you can take in an affordable way to actually increase your resilience, reduce your risk in this changing environment, really driven by climate change. So I want to really invite you to pay keen attention to all of the presentations this evening, but also to please note any questions or thoughts that come to your mind as you listen. While we will have 5 presentations in series, at the end of that, we will have a question and answer segment where you will have an opportunity to have any questions answered. Please, in order to facilitate that as we go along, post any questions that you might have using the chat function in the webinar. You can also use the chat function if you wish to have a copy of the webinar. It is being recorded. So this evening, the first panelist will be myself, and I come to you again as the author of the Irma Diaries, a survivor of Hurricane Irma, as well as Hurricane Maria, I might add myself. But I also come to you as a climate change practitioner who has been working in the region for the past 13 years and currently serving as the climate change coordinator for St. Lucia's Disaster Vulnerability Reduction Project. So my presentation this evening is going to focus on surviving a Category 5 hurricane, looking at specifically the experience of Hurricane Irma and the important lessons that we can take from that experience. As I was reflecting and preparing for this evening's webinar, a fact that has played over and over in my mind is that it has been almost 2 generations since St. Lucia has experienced a major hurricane that is a Category 3 or above. That would have been in 1980 with Hurricane Allen. So there's a whole generation plus who has no idea what that type of experience is. And I think it's so important that those of us who have gone through a Category 5, which I should note is an exponentially different level of impact from even a Category 4, and I speak from somebody who's gone through at least 2 Category 4 hurricanes as well. I think it's so important that we share that experience in very human and real terms so that people get it. And I would like to highlight that since just 2017, there have been 9 Caribbean countries that have been directly hit and devastated by Category 5 hurricanes. That represents about 1/3 of our region. So in 2017, we had Hurricane Irma, followed about 2 weeks later by Hurricane Maria. In 2019, we then had Hurricane Dorian. And we saw that all of these hurricanes were record-breaking in their own right. I've already, through the pages of the Irma Diary, indicated how Hurricane Irma at the time broke all records in terms of wind intensity. Then we had Maria come along and break records in terms of rate of intensification. So you might recall Hurricane Maria actually went from a mere tropical storm off the coast of Dominica to a Category 5 hurricane within the span of 24 hours. That's incredible. That sort of thing has just not been within our hurricane experience here in the Caribbean. And then there was Dorian, which literally stalled over the Bahamas for a startling 40 hours. Again, an unprecedented experience. And these are exactly the types of changes in hurricane experience that the scientists have told us will come as a result of climate change. So it is important that we understand these changes in risk and that we are prepared. Just to give you an idea of the scale of impact, I want to share with you some data on housing impact from the Virgin Islands. This is the British Virgin Islands, and from Dominica in the instances of Irma and Maria. So in the Virgin Islands, approximately 62% of the housing stock was damaged, whereas in Dominica, you had about 90% of the housing stock being damaged. You can see that while there was a difference in overall damage, the degree or extent of total destruction was about the same, coming in at 14 to 15% of the housing stock. In the Virgin Islands, we had 17% of the housing stock experiencing major damage. This is something like losing a house roof, and then 31% with minor damage, whereas in Dominica, 75% of the housing stock receiving some level of partial damage. The split between major and minor is unknown in the data set that I had access to. But I think the important storyline from the Dominica data is that damages totaled close to 1 billion EC dollars. That gives you an idea of the scale of impact. So this evening, what I would like to bring to the table is 4 lessons coming from very human, very real, very true experiences from the Hurricane Irma experience that speak directly to windows and doors. And I chose to focus on that this evening because I think we focus a lot on roof and other elements of the structure, but windows and doors are really critical elements of the structure that really matter significantly in terms of how well your home, your building will survive these types of intense storms. So the first lesson I want to share with you is that you do not live in a sterile environment. And by this, I mean that your home is perhaps only as resilient as your weakest neighbor is. So you can't just think about the resilience of your home, you really need to think about the resilience of your neighborhood. So for this, I will be sharing from the story, Phoenix Rising. The last call I received was from another cousin in the building who lived on the floor below and had a clear view of our unit. "Cuz, do not go to your bedroom," he warned. Of course, as though the warning were a direct invite, my human curiosity instinctively directed me straight to my bedroom. I glanced through the cracked door. The second tower and its antenna were dangling from cables. The antenna was wildly swinging back and forth, beating against my bedroom window as if knocking on our home, requesting permission to escape the madness outside. I looked at my wife, reporting the obvious. "Look, this window is not going to last." With direct exposure threatening, suddenly we became aware that there was no place to hide. Once the wind gets in, that's it. Thankfully, once the cables gave way, gravity won the battle. The tower and its antenna, resigned to its fate of no entry despite its best attempts, fell to the ground. I took another picture of the remains and confirmed in the office group chat that Tower 2 was down. That's when things really started to get bad. My bedroom window wasn't saved for long. When the antenna failed to do it in, Irma sent a brigade of clay roof tiles from our neighbor's roof to finish the job. They were nothing short of missiles. They shot through the window with shattering sounds. The orange tiles are still on my bedroom floor. I haven't gone back to my apartment since Irma. It's simply too depressing. So again, you do not live in a sterile environment. And while you might think your home is intact, if your neighbor's is not, you are very much exposed to the real risk of projectiles in a hurricane event, especially a Category 5. I think that risk is much more prevalent than people realize. The second lesson that I would like to share with you this evening is that in addition to the fairly obvious threat of strong wind and projectiles that you would experience in a Category 5 hurricane, there's another very important threat that is almost invisible, and that is the pressure differential that exists between very high pressure that can build up inside a structure in the hurricane and the low pressure on the outside. And this pressure differential actually has the ability to pop windows and doors wholesale out of their frames if they are not properly installed. So this really is to underscore the importance of properly installing windows and doors regardless. You can have impact in resistant windows. If they're not properly installed, you are still very much exposed and at risk. So for this, I will share with you from the story, Crash Helmet. Without much warning, things moved beyond the realm of manageable. Trying to hold the doors closed became almost impossible. At a point, I thought my hand was broken. It was so swollen from the strain. I remember feeling a bit shortchanged on hurricane doors at the time. While I was battling the balcony door, an invisible hand was busy opening the casement window to my left. The clips that locked the window shut were now lifted, and the window operator was spinning around, winding the window open. I immediately abandoned the door and rushed to close the window. As I did, I noticed that the next one had done the same thing. Managing to close that one also, I headed back to my post at the door. Before long, the invisible hand was opening the windows again, and I found myself in a constant, exhausting loop between the windows and the door. Eventually, I couldn't keep up, and the windows just disappeared. Fortunately, the windows blew out and not in, landing on the deck down below, remarkably still intact, perhaps with just a small crack in one of the window panes. Help, I thought, as I continued to clench the doors. I could see that they were about to go. Wondering what to do next, I turned towards the bathroom where Elaine was. Before I had a chance to think, boom, the entire bedroom exploded and the bathroom followed shortly after. Everything went flying, including the toilet. A wall was not left standing. Between the force of the explosion and the winds, I was thrown about 20 feet from the front of the bedroom, clear across the room and down behind it. Elaine was thrown as well. So a very important lesson on pressure differential and the risk that it poses. The third lesson that I would like to share is that windows are often the first point of impact in a hurricane. In fact, I was interested to look back at the 25 stories in the Irma diaries and realize just how many of them started with a simple breach to a window. And not only that, but hurricane shutters can fail, especially under the circumstances of these very strong hurricanes, a Category 5 hurricane. So for this, I will share with you from the story Gunpoint. A small rectangular glass strip across the top of the wooden living room entrance door allowed us to witness the first strike. It started when the big mango tree that towered over the outside deck gave way, collapsing in front of the entrance door. Shortly after this, we heard a relentless banging coming from upstairs. Peeping out, Tishan realized that a hurricane shutter on one of the windows had come loose and decided that she could fix it. She braved the storm and went upstairs. With that fire under control, it was only moments before another caught on and the fire intensified. It was now the hurricane shutter in my bedroom that had come loose and started to slam against the closed glass window. We shut the bedroom door that led to the living room to isolate it. Behind the closed door, we listened as the shutter beat the window without mercy, each blow sounding worse than the one before. Then there was quiet. The banging had suddenly stopped as the winds finally took the shutter away. Relief and worry hit us at the same time. While safe from a shattering window for a moment, one by one, our hurricane shutters seemed to be peeling off under the unnaturally intense force of Irma's winds. Christine and I scrambled behind Chelsea and Tishan into the safe room with only enough time to slam the door behind us before we heard what sounded like a massive explosion. In one fell swoop, everything north of that safe room, including the 2 bedrooms and the living room, was no longer standing, and the daylight, previously shut out by hurricane shutters, walls, and a roof, poured in. The house was an open sepulcher. The final lesson I wish to share with you this evening from Hurricane Irma is that doors can also be an important point of vulnerability, in particular your double entry doors or double balcony doors. For this, I will share with you from the story 21 years ago. And I want you to pay attention to that little concrete casing you see on the screen. I'll explain to you the significance of that after. Back on the main floor, things quickly spun out of control. Standing in the living room, I noticed that one of the interior sheetrock walls started to collapse in my direction. There was no exterior breach to the lower part of the house at all, but the sheer pressure and wind force was shifting the wall off base. In pure desperation, I took another length of 2-inch by 4-inch wood, chopped it up against the base of the wall and nailed it into the floor to try to hold the wall in place. Things escalated to another level when the solid wood main entrance doors that had been bolted shut blasted open without warning. I slammed them again and dragged a heavy wooden table from the deck across the doors to hold them in place. In no time, the wind blew it away like a feather. Defeated, I went back to my fight with the wall. While losing that fight as well, I soberly realized that the adjoining bigger living room wall was also collapsing in my direction. In that moment, you surrender and say to yourself, this is more than me. I acknowledged that there was nothing I could do. The walls would go. It was then that I was overcome by feelings of powerlessness, hopelessness, defeat, and a tremendous sense of loss at what was about to unfold. I knew that I was about to lose everything, and there was absolutely nothing I could do. Now I'm going to end there, but I want us to reflect on those last few words. In that moment, there was absolutely nothing that Albert could do, but I was inspired by the fact that in interviewing Albert some weeks after the hurricane, his attitude was a very positive one towards the future and rebuilding. And I want to just share that with you. Irma has presented a challenge. I have accepted and intend to conquer it. Since Irma, I have heard someone on the Weather Channel say that over the next 10 years, the Caribbean will experience more frequent, stronger hurricanes. So I'm not building for category 5. I'm building for category 10. Irma got me in round 1, but I plan to be ready for round 2 in my new bunker. It's adaptation time, better, bigger, stronger. And that's the message that I want to leave with you tonight. Albert was able only to save his life because of that casement that you saw, that concrete casement, which was actually built to house his water heater. That is where he sheltered when his entire structure disappeared. And that's why the story is titled 21 Years Ago. It was a chance decision that he made against the advice of his builder to actually put that concrete structure in place to house his water heater. We don't have to allow ourselves to get to the point of that total devastation that Albert experienced. We can take on the attitude now of better, bigger, stronger before the impact. So again, I invite you to listen to the words shared this evening by our experts so you can understand how to build better, bigger, and stronger and avoid the type of experiences captured in the pages of the Irma diaries and that happened to various persons in Dominica as well. So with that, I'm going to end my segment of the readings and just quickly share with you, I think, 2 very practical and important tools that you can use right here in St. Lucia to go about the business of making your home more resilient. The first is the Act to Adapt app. This has recently been launched by the SLDB, the St. Lucia Development Bank, through its climate adaptation financing facility. Essentially, it's a web application. Anybody who can access a website through a device can use the app. It is freely available and it helps homeowners to basically go through a very simple step-by-step guided assessment to understand and actually estimate the level of impact that their home would experience in a Category 5 hurricane, but not just that, actually understand the points of weakness, points of vulnerability in the structure, and be able to appreciate the types of improvements that they can make and actually see how those improvements will up the ante, will actually help them to increase their resilience. So I encourage everybody to check out that app. It's being run right now for the purposes of a school competition, but is open to the general public as well. And finally, I want to briefly mention, I will circle back to this a little later in the presentation. So right now you can see a snapshot of what the interface for the app looks like. I want to just briefly mention the Climate Adaptation Financing Facility itself. I think this is such an important facility, again, administered by the SLDB, actually as a component of the Disaster Vulnerability Reduction Project. And this is an opportunity for homeowners, business owners, farmers to access very low cost, affordable financing to be able to implement any measure, including putting in hurricane or impact resistant windows and doors that would build their resilience to climate change impacts, including stronger hurricanes. So thank you so much for your attention to these personal experiences and to tools available to you right here in St. Lucia. I'm going to now introduce you to our next panelist, Mr. Jamal Francis, who will speak to you on design considerations for new and existing buildings. Jamal comes to us very qualified as an architect by profession, who has been practicing architecture in St. Lucia and the Caribbean for 15 years, but who has 24 years of experience in the construction industry. He has training in post-tension concrete design, placing and supervision, precast concrete design and production, arbitration and dispute resolution, project management, and general insurance. He is a registered architect, a lead green associate, president of the Guild of Graduates of Cuba, president of the Institute of Architects of St. Lucia, and the director of the Design House Limited, which is a consulting firm specializing in architecture, mechanical engineering, and electrical engineering. I don't think we could have had a much more qualified person to speak to us on this topic. So Mr. Francis, I hand it off to you and certainly look forward myself to your presentation. Thank you.
Thank you very much, Angela. And welcome to all those on our Facebook live stream, hopefully on our Instagram and directly on this web page. Angela has certainly covered, well, giving you, I hope, a clear picture of what it's like to go through a Category 5 storm. I can't really remember too much from Hurricane Allen. I was a very little boy at the time. I remember part of the roof being lost and that sort of thing, but not much of it is retained, you know. So I myself have not been through it, but I've seen the devastation in Dominica and a couple of the other islands. I remember Grenada had been damaged by Ivan years ago. So I'm going to try to go through the basics that one can look at in whether you are currently building, planning on building, or you have your existing home. What can be done to ensure that you have, or to try your best to have a hurricane-resistant home? Let me start off before even reading the threats. Let me start off by saying one of the first things you should ensure if you're currently building or planning on building, try to get professionals involved. I mean, your home or your building is one of the biggest investments you will ever make. So try to go all out to make sure it is designed and built properly. And supervision is a big part of it, not only the designing of the building. So what are the main threats to your home during a hurricane? Flood waters, land slippage, wind pressure, and missile strikes. A lot of persons in St. Lucia would have experience, would know about flood waters. We have a lot of flood areas in St. Lucia that are prone to flooding. Land slippage as well is something that's common to us. However, those two are not usually something that you personally can do much about. It usually has to do more with what is in the community, what is in the neighborhood, the infrastructure in place. But apart from appealing to the authorities to ensure that rivers are cleared prior to the hurricane season, etc., one of the main things you can do, well, if you're building or you're planning on building, I would suggest whatever land you have, get a professional to do some soil tests for you. Check to ensure that the area you're building is stable. There are many areas in St. Lucia whose soil types don't really support large houses. And especially, you have to look out for the drainage in the area where you're going to build as well. If you're just buying land, look for an area where there's proper site drainage, large box drains to take all of that rainwater away. If you have built already, I would say try to ensure that all of the rainwater coming off of your roof runs down drainage pipes and into your site drains, which then connect into the community drains. It's important because you'd be surprised how much water comes off of your roof. And the larger your house, the more water you have coming off of that roof. And if all of that water is going into the soil directly around your foundation and you're on a slope, you're making that soil more prone to slippage. As I said, apart from controlling your rainwater runoff, etc., there's not that much you can do about land slippage, unless, of course, you get the authorities involved. I would also suggest speaking to your neighbors. If you have a neighbor above you who does not control their rainwater runoff, speak to them, speak to the authorities about it. There are things in place that can force persons to install proper drainage on their site. So in this slide here, you can see what happens when you build on subpar soil or when the site drainage is not adequate. These are both examples of land slippage. The one on the left was last year in St. Kitts, a massive house, massive investment, an apartment building, went sliding down the entire hill. You can see from
Whoops, it looks like Jamal's internet is frozen. While we're waiting to have him come back, perhaps I'll go ahead. This is Terry Ort from Domus. So if you do get reconnected, Jamal, please just come in. But in the spirit of keeping things going, first of all, there are many different roof types, and just to say that the hip roof is the best kind of roof to have, because it has the least amount of impact or exposure to the the winds. Yeah, it looks like Jamal's dropped out. So what happened?
I apologize. I'm not sure what happened. Where did I get cut off?
You just before we pulled up the slide, you talked about the house sliding down. So I pulled up the roof and was just mentioning hip roofs are probably the best to have. But go ahead.
Okay, all right. Let me just reconnect to. Okay, I think our Facebook stream is back on. 1 second. Okay, yes. So as I was saying, let's move on to the things that you can control. This slide basically gives you an idea of how wind pressure affects your house. Terry, can you go back to the previous slide for me, please?
Sure.
Right, so this slide gives you an idea of all the various types of roofs that, well, not all, but most of the types of roofs that are used in the Caribbean and most parts of the world. The best design for our region is the hip roof or a flat roof, flat concrete roof, that is. It's not, gable roofs are fine as well, as long as they're well braced, but move on to the next slide, Terry. As you can see here, a gable roof provides a flat area into which the wind can dig in and apply a lot of pressure to rip that roof off. So a hip roof slices the wind a bit better. The wind contours over the roof, and there isn't as much surface area taking direct pressure for the wind to destroy. This here, if you have a look at this, it explains how the wind pressure is built up on a house. So whichever side the wind is coming from, that is where the most pressure would be applied to the house, right here. This part of the roof on a reasonably sloped roof. Now in the Caribbean, the sweet point for a roof, the most adequate slope is considered to be a 30-degree roof. A 30-degree roof in the Caribbean typically holds up best in a hurricane. Anything steeper, and what happens is If this side of the roof is steeper, you start to get more pressure against it. Also, on the other side, you will get more suction because the wind, as the wind goes over, it creates that swirl and pulls against the roof on this side. A shallower roof, you would have less suction on this side of the roof, but on the previous side, on the side taking the wind, you will actually build up suction as well, the shallower your roof is. A flat concrete roof, you will get suction on it, but because it is a concrete roof, it's not as easy for it to be lifted off. This sketch up here to the top right shows, it's suggested that if you have open balcony roofs, that you try your best to ensure they're not directly connected to the main house roof. In the top image, you can see that if a balcony is a weak point where the wind can gather under the roof and lift it off. If that piece of roof is lifted off and is connected to the main roof, it's a chain reaction, everything is ripped off. If it's separated, then there's a greater chance that you will only lose your balcony roof. And then the wind now has to try to contend with a whole other roof, which is still intact. Okay, so if you are building, if you are designing or building, this is a suggestion for your balcony roofs. Try to separate it from the main roof. If you have an existing house and your balcony roof is connected to your main roof, it is still within the realm of possibility for you to remove the roof over the balcony and create a second section of roof just below the eaves of your main roof. Okay. Next slide. Okay, so here I would like to speak to what happens when, I remember as Angela said, one of the main ways that houses are destroyed in a hurricane is when windows and doors fail. Whether it's because you didn't have impact-resistant windows or the windows weren't pinned properly, you need to ensure. Well, sorry, this is how the wind reacts when it enters the house. If the wind comes in through one window and there's no other opening, it is going to try to find an exit. It is either going to blow out another window or it is going to go up through the roof and rip the roof off. Open plans and cross ventilation will help save your roof by another window being blown out. So in other words, if there was a window on the other side of that wall, the wind could then rip straight through the house. Of course, it would take all of your belongings, but your roof might still be saved. If now you don't have cross ventilation and there are a lot of walls between one window and the other, it's the same thing. The wind pressures will build up in there and the roof is liable to be lost. Couple of points. The size of your windows obviously make a difference. Now go back, Terry. The size of your windows obviously make a difference. The bigger the window, the stronger it has to be. So try to ensure that you get it from a reputable supplier, that the frame is strong, that you have impact resistant glass, laminated glass, which can take a missile strike. And the installation again of impact resistant windows is important. The manufacturer will usually let you know they will usually provide the screws to install the window. They will indicate on the window where the screws should be installed. Ensure that you use those screws from the manufacturer. If you do not have impact resistant windows, ensure that your windows are well screwed, top, bottom, and both sides into the wall. 3-inch screws, the bigger the better. You want to ensure that that window is well secured into that wall. And in the Caribbean, we usually advise people that when you are installing a window, you try to ensure that the plaster on the inside of the house overlaps the edge of the window. That helps to provide a bit more pressure, a bit more resistance against the wind pushing that window into the house. Okay. As Angela said as well, the walls themselves can fail. Even if your windows don't fail, even if your roof doesn't fail, your walls can fail you. And of course, if the windows and the roof fail, it's even more likely that the walls can fail. What will help your house stand in a hurricane is not the concrete blocks themselves. Concrete does not flex. You need steel in those walls. If you're now building or planning on building, ensure that your design caters for vertical and horizontal steel. This will help not only in hurricanes, but also in earthquakes. And you need to ensure that this steel running both ways goes from foundation all the way up to the ring beam. And if you have a concrete roof, into the roof as well. That ties your roof and your floors down to your foundation, which is then under the soil. So everything is tied together, it holds together well. On the right here, you can see the sort of failure you can expect if you don't have that vertical and horizontal reinforcement. Now, what is shown here is something called brick force. You don't necessarily have to use this type. There are details where you use a single bar running through every course or every other course of blocks, and that ties itself all the way around the house, ties the vertical reinforcement together as well, and the vertical reinforcement, as I said, goes from foundation up to ring beam. Next, sorry. In a timber structure, and remember people, I always try to remind people that timber structures can survive these hurricanes. I've heard many stories in Dominica of persons abandoning their concrete houses and passing the storm in the little timber house next door with their uncle or their grandfather, which stood up to the hurricane. Because timber flexes, it moves with the hurricane. It moves with the winds and the pressures. But of course, it has to be built properly. Everything has to be anchored. Everything has to be screwed. Do not use nails. Use screws. You want to ensure that or bolts. When you are running your bottom plate to the floor, try to bolt it onto the floor. Don't use screws or nails. You want to ensure, because this is what, in a concrete house, remember you had the steel running into the foundation. In a timber house, you don't have that. This is what secures that bottom plate to your floor and to the concrete, to the foundation, sorry. So as you can see here, hurricane straps can actually be used to secure your vertical members to the horizontal members, both at the bottom and top of the walls. Bracing is important as well. If you're currently building a timber house, try to ensure that you have bracing at all the corners. If you have an existing timber house, it's pretty simple for you to open up certain sections and include bracing in those corners. Timber houses are a lot easier to renovate in that regard. Okay, let's move on to the next thing. Roof connections, hurricane straps have become pretty commonplace in St. Lucia. Everyone knows of them. I think most people by now understand that you need to have hurricane straps. However, the installation of hurricane straps is important as well. If you have a concrete ring beam or concrete walls with a ring beam on top, you need to ensure that your the best way is for a hurricane strap to be cast into the concrete, protrude out of the concrete, and then your rafter is then screwed on to that hurricane strap. Many times persons will install a rafter, and sometimes you see a contractor just run a steel bar through the rafters and then cast it. That actually weakens the rafter. Try your best not to do that. The best, the most advisable solution is to have your straps cast into the ring beam. On a timber house, it's the same way. You have your double top plate. You can have those hurricane straps screwed directly into your top plate and onto the rafter. Bottom left image. This shows the bottom left image there. That image there shows how to extend or how to join two rafters. If you have a very long span and you have to connect two pieces of wood, it's not advisable, but if you have to do it or if you have it existing currently, try to ensure that you have metal plates at those joints. I know that the contractors or the carpenters may put in special timber connections that they are custom using, but the best thing is to have metal plates. You also, if you have very large spans, a collar tie can help to save your roof. If you have small rafters as well, I know a lot of people use 2x4 rafters. try to brace it with a collar tie. It doesn't even have to be all the way at the top. You can use multiple collar ties. You can have a collar tie all the way at the top with these hurricane straps connected onto the ridge board, or you can also include horizontal bracing below that to create a triangle in your roof that will hold your roof together a bit better. Next slide, Terry. This example, these images show on your left how the simplest way of installing these hurricane straps. You use, before you cast your ring beam, you have them inserted. You can see there's a piece of steel, a piece of horizontal steel holding them onto the reinforcement of the ring beam. And then you have a piece of wood to hold them in place. That piece of wood ensures that it stays where it is so that you can keep your rafter spacing. Okay. On the right-hand side, it shows the rafters being sat onto a ring beam that does not have hurricane straps. What some people tend to do, you'll see vertical steel protruding out of the ring beam. Some people tend to just have a piece of steel protruding out and they bend it over the rafter and put a couple nails in it and call that a strap. It doesn't work the same way. These can be, when the pressure from wind starts to impact that house, those will raise off. This image shows what happens when you have a span that is too large. When your span is this large, you will have failure in your roof. The pressure from the wind bearing down on that house will snap your rafters, unless you have massive rafters, 2x8s, 2x10s, that sort of thing. You try to keep your span as minimal as possible. And some of the ways to do that, you can ensure that your internal walls come all the way up to your rafters. That will help to break the span, provide some support. You can see the collar tie at the top. As I said, you can install another collar tie below that if you want. All of this helps to brace your roof and prevent it from buckling under the external pressure or even the internal pressure. Your roof covering is important as well. You want to ensure that it's screwed down and not nailed down. Whether you're using regular galvanized or you're using any other type, standing seam, U-panel, etc. You want to ensure that they are screwed down with screws with washers. And the code suggests that to the edge of the roof, in those shaded areas, towards the edges of the roof, you want to ensure that at every rise, you have a fixing. You have a screw at every ridge. So if you look at that image to the top right, it shows at every ridge, you have a screw penetrating those, penetrating your timber members. Outside of the edges, well, inside of the roof area, so away from the edges, you can have it every other. You can increase it a bit there, but at the edges, which is where the lift force is strongest, you want to ensure that you have it at every ridge. Okay, this is, well, basically a simple example of what happens when your roof isn't fixed securely, or when you have a thinner gauge of metal. You also want to ensure that the gauge of your roofing is sufficient. Don't go for the cheapest and the thinnest gauge just because it's cheapest. You will pay for it in the long run. Next, Terry. So in closing, I just wanted to run through a couple of things. Remember, as I said, it's in your best interest to use professionals for your projects. Not everyone who knows how to use a drawing program and can produce pretty renderings is qualified or experienced enough to give you a good design. Keep in mind that it's, as I said, it's a major investment on your part, and registered professionals tend to have liability insurance. They take liability for any design that they do, and if they supervise it, they will take liability for that as well. So if anything, they can be held account if anything goes wrong with their design. Building form, fenestration, which is the windows and doors, and structural integrity all play their part in making the home resistant. So don't pay attention to one and ignore the other. They all tie together. ensure that you have someone independent of your contractor overseeing or double checking their work. This is very important. I keep stressing to people that supervision is important. A contractor having their foreman on site is fine. Their foreman is looking out for their interests. He's trying to ensure, yes, he may try to ensure that the quality is maintained, but you want to have someone outside of the contractor's influence to review their work, especially at important parts. When you're casting a deck, you want to have someone review the steel in that before it's cast. When your blocks are going up every once in a while, you want to have someone ensuring that the horizontal and vertical steel is continuous and that the cores are being filled around that steel. When your roof is being installed, you want to have someone around to ensure that they're putting in the screws at the correct spacing, that sort of thing. So again, supervision. Existing homes can usually be upgraded to improve resilience. Engage your engineer or your architect to assist in identifying any deficiencies you may have in your home, and they can usually suggest some remedies to those. Many financial institutions, as Angela mentioned, have financing available for home improvement, and it's usually with better rates of interest. And don't forget that being self-sufficient after a storm is critical. So pay attention to your rainwater collection. Ensure that you have at least one water tank that is fed from your roof. There's a system called First Flush. I think we may try to address that in another webinar. I know Mr. Emmanuel was a part of developing that on the island as well. A First Flush system, what it does is it ensures that the first set of rain that runs off of your roof does not go into your water tank. It's flushed away down the drain, and then after the first volume of water rushes off, then the tank starts to fill. It's a pretty simple system. Your professional should be able to guide you on how to have one installed, but that will help ensure that you don't have things like bird and rat droppings going into your rainwater tank. Of course, you're not going to drink that rainwater, but at the same time, you just want to be on the safe side. And if you can, try to have some sort of backup power available. It's not the cheapest, but from all accounts, you will appreciate that investment if we end up in a situation like the British Virgin Islands, Dominica, etc. God forbid, of course. That is it for me for this evening. Pass you back on to Angela.
I was just going to say we're running a bit behind, so I'd ask the other presenters to move along, and I'll try and do the same in my last presentation. Angela?
Yes, so thank you so much, Mr. Francis, for that very informative presentations, sharing such practical information. Me as an aspiring homeowner, I was listening to every point, and I've learned something new from that presentation. I'm sure everybody in our audience has as well. So thanks again. I think this is usually the information only architects and engineers are privy to. So we appreciate you bringing it to us in very real and understandable terms. I will next turn directly to Mr. Vern Emmanuel, who will be sharing with us on the topic of national quality infrastructure. Again, coming to us very qualified. He's a chemical engineer who possesses advanced practical and technical knowledge coupled with a passion for continuous improvement through the use of clean technology and best practice. He has a proven track record in developing efficient water and wastewater quality management systems in the process industry and implementing successful environmental management initiatives in sustainability projects. A professional engineer in St. Lucia and the Bahamas, Mr. Emmanuel is the director of the St. Lucia Bureau of Standards, the immediate past president of the Association of Professional Engineers of St. Lucia, and the chair of the Engineers Registration Board of St. Lucia. Mr. Emmanuel currently serves as president of the St. Lucia Coalition of Service Industries, chair of the board of directors of the Vaughan A. Lewis Institute for Research and Innovation, director of the Pan American Standards Commission, board director of the St. Lucia Solid Waste Management Authority, and board member of Export St. Lucia. I don't think it's possible to serve on any more boards, Mr. Emmanuel. Thank you so much for your service to St. Lucia and the wider region. And I now hand it over to you for your presentation.
Good evening. Thanks, Angela. Um, Carrying on from where Jamal left off, the the need for the use of proper professionals and proper building standards is key to ensuring our sustainability and resilience. Our national quality infrastructure is managed by the St. Lucia Bureau of Standards, whose mission is to strengthen the quality infrastructure of St. Lucia in order to contribute to the advancement of the national economy, support sustainable development, promote health, safety of consumers, protect the environment, and facilitate trade. We are a ISO 9001-2015 certified organization. It's also the National Legal Metrology Institute. We received the 2015 OIML Award for Legal Metrology, and last year we were also awarded accreditation to ISO 17025 for calibrations in mass and volume. St. Lucia Bureau Standards is a member of CrossQ, which is the CARICOM Regional Organization for Standards and Quality. We're a member of the Pan American Standards Commission and a full member of ISO, the International Standards Organization. The key elements of the quality infrastructure, which is critical in promoting and sustaining economic development as well as social well-being, are standardization and technical regulations, metrology accreditation, conformity assessment, market surveillance, and quality promotions. As we move to the reflect on how the quality infrastructure interfaces with the wider economy in ensuring sustainability in terms of business concerns related to trade quality, profitability, distribution, purchasing, the use and understanding of specifications and contracts. Metrology, measurement and traceability, standardization, the development of international and national standards, conformity assessment in terms of testing, inspection, certification, and accreditation. So in our building, this all brings us to a net result to address all societal concerns of health, safety, environment, economic well-being, fair trade, consumer protection, and regulations. The role of the demand-oriented quality infrastructure is essentially broken down into three main areas of policies and trade agreements, and the regulated area, which is controlled by the state, where you have ministries, technical regulations, market surveillance, and conformity assessment on mandatory items such as some building materials, and then the non-regulated area, which is market driven, with the area of standards, accreditation, testing of products, inspection of products, product and personnel certifications, quality system certification, productivity, innovation, competitiveness, calibrations, all meant to assist the public, buyers, and industry. The national quality infrastructure consists of the National Standards Body, the National Metrology Institute, testing and calibration laboratories, certification bodies, inspection bodies, accreditation bodies, information and awareness. We are part of an international network which allows us to do the necessary conformity assessment for both building materials and manufactured products. SLBS has agreements with ASTM International and UL to allow for the conformity assessment of all products coming into St. Lucia and all products produced in St. Lucia. In 2015, the OECS building code was revised for with a special application to St. Lucia. The code is not a standalone document and it must be used in conjunction with other design codes and reference documents. The specific areas of our building code with regard to hazard forces is design wind speeds and design wind pressures, which was updated, which is section 12, wind speed increases expected due to climate change, earthquake spectral accelerations for St. Lucia, and rainfall intensity frequency duration curves for St. Lucia. In 2018, the CARICOM Energy Efficiency Building Code was approved, and it is built on the International Energy Conservation Code. One of the key areas for the Energy Efficiency Building Code, specifically with regard to windows, is the general area of glazing, which is what is the solar heat gain coefficient. The solar heat gain coefficient is an important coefficient, the most important characteristic for fenestration in hot climates. Right? In dealing with the solar heat gain coefficient, one of the critical areas are the projection factor, which is the ratio of the depth of the leading edge of the overhang to the face of glass over the height from the bottom of the leading edge of the overhang to the top of the window sill. Next slide, please. Jamal would have shown specific areas with regard to overhangs, and the energy efficiency code deals with most of them, especially based on your solar heat gain coefficient and the orientation of your building, where the projection factor is directly linked to the solar heat gain coefficient. The other specific area for windows is the fenestration air leakage, and the building code speaks specifically to areas of windows, sliding glass doors, and skylights, along with exterior swinging glass doors. For example, we have an example here of what a conformity assessment certificate, which accompanies a certified window, would look like, indicating where the window would have been tested for its energy performance ratings and additional performance ratings for visible transmittance and air leakage. In closing, I would like to encourage you to visit the SLBS's website. We have a list of national standards and building codes, and we can make available all the necessary measures to ensure quality in your building performance. Thank you.
Thank you so much, Mr. Emmanuel, for sharing with us, enlightening us on the infrastructure that exists in St. Lucia to ensure that we're observing the highest standards. I think we can safely say that the Bureau of Standards has us well covered. It's good to know we have a solid infrastructure in place. So with that, I will now turn you over to Mr. Winsbert Felix, and he is going to explore the cost aspects of resilience. So just a little bit about him before he dives into his presentation. He's a chartered quantity surveyor by profession with over 20 years of experience in professional quantity surveying, commercial management, and project management. His experiences are broad-based with international, regional, and local components spanning various sectors, including hotel and leisure, housing, commercial offices, healthcare facilities, supermarkets, retail banking, fire stations, power stations, airport development, FBO's development, road infrastructure, courtroom facilities development, mechanical and electrical services, major project audits, and hurricane damage assessments, insurance claims, settlement recoveries, and litigation support to the built environment. So very, very broad base of experience. For the past 14 years, Mr. Felix has been involved within the hotel and tourism industry, advising the hotel owners directly on strategic development options within the Caribbean, in particular on islands where they own and operate properties or wish to expand. He is the former president and director of the Institute of Surveyors of St. Lucia. So I now invite you to sit back, relax, and enjoy Mr. Felix's presentation. Over to you. Thank you.
Winsbert, you're muted.
Sorry about that. Good evening to all. I will try to give some insight into the cost aspect of resilience, in particular after a hurricane or natural disaster. The next slide, please. Resilience basically comes down to one key issue: your ability to bounce back financially from a natural disaster. Most persons would recognize that the biggest investment that they would make in their lifetime is to build a house or have some kind of commercial investment. Next slide. Essentially, after a major disaster, the key question, or should I say the acid test, is do you have sufficient funds so that you can bounce back, or are you adequately insured? We must recognize why people build their homes. First, for shelter, security, as an investment purpose vehicle to start their families. Traditionally, some families require by the time you turn 18 or 20, you should move into your own home. Some people, it's a status thing. You know, they made some money, then they want to show that they can afford a very nice house. But it comes down to that key question: how much does it cost? And you'll be surprised to see the reaction. The first thing is that it's too expensive. Or can they get something cheaper, or are there other options that are available? We will see that cost. Sometimes you might be fortunate enough to buy into a planned development, but there are other persons who may not be that fortunate and may have to just settle for unplanned developments by setting up their shingles by any means necessary. One of the key things after disaster is to look at, in fact, the cost drivers is the availability of labor. For example, if a storm strikes today, the craftsmen would basically try to fix their own buildings first, and thereafter go and fix another person's building. There's also the issue of availability of materials. We live on an island, and we have to fly things in. The lead time might be 4 to 6 weeks, and you may not have all that time to put a roof over your head. The other thing is the availability of standards. People build based on what is in the marketplace. So it's pointless me telling you to get a hurricane-proof window, and I cannot find it in the local marketplace. The other issue to look at is the enforcement of the standards. Cayman Island does a very good job of that. Every section of your development, it has to be inspected, certified before you move on to the next stage. We look at the availability of information. If people do not know any better, they will stick to what they know. And of course, this is why we encourage you to get professional advice. The key issue, it comes down to budget constraint. How deep is your pocket? In all of this, our housing stock is a reflection of our economic situation. Most persons would want to have the most durable structure. Unfortunately, it might be something that you just cannot afford. On the other hand, we have a property tax system that is skewed in terms of promoting inferior housing. If you look at Barbados, for example, most houses would appear unfinished because people do not want to pay that excessive property tax. So they may either choose an inferior alternative. Society must recognize that the vulnerable, as I showed in the slide before, may not be able to afford the luxury of preparing robust structures. So in situations where we have our community centers, etc., we have to ensure that they are robust. Now, cost, you must look at three main components: the initial, the maintenance cost during the life of the structure, and then the replacement cost thereafter a storm that you need to get over. I've tried to create a number of work examples, one indicating an ordinary window and one that is hurricane impact window. There's a general uplift on the impact, about 30%, but then you would recognize that, can you go into the next slide, please? The overall impact would be about $135 if you have to look at changing the normal window to the hurricane impact window. The maintenance aspect of it, in the normal window, you might need to change a few parts and grease the parts. In the hurricane impact window over a 10-year period, you may not have the option of changing anything because it's built out of robust material. And you look at the cost implication there, it will work out to about $102 based on the work example I've shown here. I'd like to show you another example about the reinstatement cost. You look at the initial cost that you purchase that normal window, and the cost of the impact window. Now you may have to replace that normal window twice. So basically, you know, where you could have had a simple spend of $510 in the first instance, sorry, where you should have simple spend of $540, now you have to put in an additional $510. Next slide. Sorry if I'm running, I'm just trying to catch up with time. I try to create a situation looking at the general fabric of the building. Look at the various elements, the roof, the wall. Now, this is a building of 1,400 square foot with a cost limit of $450,000. If you look at against the roof element, which attracts $63,000. So in case a hurricane or a major storm came about, you would have to look at expending another $63,000 plus. You may have to look at other costs. Can you click the button? Such as inflation, demolition costs. You may have to take out the bits that remain. You have to dispose of that. And at that time of replacing that element, the cost may have been inflated. There's the additional professional fees in terms of the guidance required. And of course, the planning and statutory fees in order for you to get the necessary approval to move forward. Next slide. There are additional cost factors, such as you may now have to incur additional increased insurance premium. You will also incur delays and disruption costs. You may have to move to another property whilst work is being conducted on your property. And there's that emotional cost, the loss of, you know, items that memories, fond memories were created. And the worst thing that could ever happen is the loss of life. That's a massive cost. Generally, it will cost you cheaper to ensure that the entire building envelope is resilient to natural disaster. Or, sorry, it will cost you cheaper to ensure that it is resilient, because you will pay for the reinstatement cost in the future. By that, most people will think that I'm saving something here, but they may not recognize that the extra $90 that you may incur initially in the initial capital outlay may end up being cheaper in terms of opportunity cost. Next slide. We in the Caribbean tend to be rather reactive as opposed to preemptive in our approaches to things. I'm cautioning everyone here to take the approach to ensure that, you know, you adapt your existing structure, make the necessary modifications, pay the additional, or you'll pay the additional cost in the future. If you're going to be building a new structure, ensure that, you know, all the components are resilient. It will be a costly element, but again, it will be discounted over time. I am aware of local financial institutions who offer climate adaptive financing. I did mention that about long term, but one of the interesting things, I just want to, before you go on to the next slide, mention something. Our GDP component, when we look at our build stock in particular, you'd recognize that St. Lucia, we project $12 million from 2016, 2017, 2018 per annum. And based on property tax rates of 2.5% for residential, 4% on commercial. That would indicate our stock value of $1.92 billion for the residential property, $1.8 billion for commercial, giving us an overall $3.72 billion asset worth. If I recognize in Angela's previous slides, in both of the disasters, Irma and Maria, 15% of the stock was damaged. So if I did a quick calculation, then that would amount to about $558 million that we would probably have lost in terms of our equity. So clearly, the cost is significant and it has a major impact on our overall GDP. And it would make sense to invest make a prudent decision and put in the right cost in the beginning and save yourself the pain in the long run. Thank you.
Mr. Felix, thank you so much for that presentation. I think you very clearly outlined the case, including the financial case for the benefits of building resiliently upfront and not only saving yourself the cost, but also the emotional turmoil and so forth of going through the sort of destruction that we saw in the other islands. So we are now ready for our final presentation. And if I may say so, the man of the hour, Mr. Terence Ott. He is the CEO of Domus Windows Limited and Doors Limited. But before I go into his bio proper, I want to just give you a quick bit of backstory as to how we've gotten to where we are today with this webinar, for instance. So 4 years ago, Domus Windows and Doors Limited embarked on a mission to reshape the Caribbean-based construction sector through its Building Smarter initiative. The goal of the company through this initiative is to educate the CARICOM community on the factors attributing to building failure from intrusive forces of impact and to collaborate with other experts in the construction sector on this issue which continues to threaten the security and livelihoods of CARICOM nationals and foreign investors. Mr. Ott, many call him Terry, after attending the Royal Military College of Canada, flew jets in the Canadian Air Force. Before moving to the Caribbean in 2000, Mr. Ott was the CEO of Canada's largest integrated hotel company with 24,000 hotel rooms in the portfolio, serving 2.5 million guests per year. He has a wide range of management and technical experience in the areas of hurricane resistance engineering, information technology, finance, hospitality, real estate, and fenestration. Mr. Ott is recognized as a leading authority in hurricane resistance and has built the only test laboratory in the Caribbean capable of testing both wind load and missile impact. Mr. Ott is the Chief Executive Officer and founder of Domus Windows and Doors Limited and spearheads the specialized manufacture of certified hurricane-resistant windows and doors. I think we can all say a big thank you for bringing this important service, I think, to the Caribbean, to the CARICOM region. Mr. Ott, thank you in advance. I know that you will be sharing with us some very crucial information. So I turn it directly over to you. I see you have up the slide with the climate adaptation financing facility. So do you still want me to spend a moment and just share a bit more on this?
Yes, please, if you would.
Sure. So as I mentioned before, the CAF, as it is called in short, is essentially a facility administered through the SLDB, that's the St. Lucia Development Bank, which allows persons to access very low-cost financing to basically make their homes, their businesses, their farms more resilient to climate change. So anybody in the housing sector, any homeowner that is, if you're a farmer in the agricultural sector, or if you are in the tourism or any services-based industry can access this facility. The interest rates, they range depending on the particular industry and your credit risk, etc. But they start as low as 4.5%. And without going through the long list here, essentially in a nutshell, I can say that any of the various improvements that you would have heard this evening, for instance, coming out of Jamal's presentation, in terms of measures that you can take, retrofitting your roof, installing the right types of windows and doors, making sure that they're properly installed, retrofitting your walls, looking at proper drainage, looking at rainwater harvesting systems, backup generators, that sort of thing. All of these things, renewable energy alternatives, all of these things can be financed through the climate adaptation financing facility. It's specifically designed for that purpose. Also recognizing the financial hardship that has come about as a result of the COVID-19 pandemic. Just recently, the CAF has expanded its offerings to include what we call the Business Recovery Program, which is specifically focused and targeted at the business sector, and essentially recognizes that in order for the business community to build resilience in this environment, we also have to help them through the pandemic. So essentially that offers a combined package of a grant loan facility to any business impacted by COVID
And they're through that facility able to access funds for business continuity as well as funds for building resilience to climate change. So anybody who wants to find out more can simply visit the SLDB in person, or they can visit their website, sldb.lc, where they can access more information about the CAF and about the Business Recovery Program. So Mr. Art, with that, I would like to hand it back to you for your presentation. Thank you.
Thanks so much, Angela. So I'm going to be talking about reducing hurricane and flood risk. And I know this has already been covered, Angela covered it, but just to reinforce, the fact is that human-caused global warming is causing hurricanes to be stronger and much, much more destructive. So these hurricanes are intensifying earlier. Generally speaking, they used to pass the Caribbean as tropical storms. Now, if you look at both Irma and Maria, they were Cat 5 before they hit the islands. So these hurricanes are delivering much more rain and causing a lot more damage. I'm going to explain why there's so much more damage to a high Cat 5 hurricane. Just keep in mind, the strongest ever hurricanes in the Atlantic was 190 mile an hour Hurricane Allen in 1980, which I think hit St. Lucia, not the full bore, and also Dorian in 2019. So why do hurricanes cause building damage? So this particular picture is very illustrative. This is, you can see that the large window in the side of the house failed. The wind got inside and it exploded from the inside out, which is why you really want to keep the shell of the building intact. So in most building destruction, it starts off with windows and doors failing first, or the hurricane shutters. Then pressure builds up inside through the openings, and the internal pressure lifts off the roof, either partially or the walls are pushed out. You saw this very often in Dominica, where a corner of the roof would be lifted and not the entire roof. But when all of this happens and the roof disappears, then the whole structure can fail. And you certainly saw some of those pictures from Irma and Maria as well. Now, the reason that very intense hurricanes are so dangerous is the wind force. If you look at a category 1, you're talking about 15 pounds per square foot. Get to a category 3 and you're almost triple that. But if you get up to Irma and Maria, then you're up about 5 times the pressure on the windows, the whole structure, that you would have in a category 1 hurricane. That's also 3 times a Cat 2 and about a double from a Cat 3 and into Cat 4 territory. So the extremely high pressure of these intense hurricanes, the wind load, is really the thing that kills buildings. And that was very obvious in the BVI, in St. Martin, and also Anguilla. So the reason that there's so much force on the roof is that when it gets inside, then it builds up pressure, and all of that is distributed around a roof. If you had a 1,000 square foot building, which is not a very large building at all, and you only had 75% of the wind load pressure inside, you can see that when you get up to the most intense hurricanes, you could have up to 20, 30 or more tons of lift on that roof. Well, I'm sorry, whatever you do to the roof, it's going to go, because that amount of lift is just irresistible. So windows and doors failed, as you saw in the video, either from airborne debris. Another one, which happened over and over again in St. Martin, was rubber gasketed windows. If you have rubber gaskets around the windows, then there's no way that they are going to survive a hurricane. Either they get hit, even if you've got laminated glass in there, the glass is going to flop around and pop out, or in many cases, the glass simply just bends and pops out. And in St. Martin, you saw the vast majority of windows and doors failed for that being one of the reasons. The other thing too is the wind force can cause the entire window or door to be removed totally from the opening, either due to structural failure of the window and door, just simply not strong enough to stand up to that kind of pressure, insufficient fasteners around the perimeter, the fasteners are too short so they bend and pull out under wind load, or you can use steel fasteners, which when put into concrete with a concrete drill, you have all of that concrete dust in between the two edges of the window. Then moisture builds up, that creates a toxic mix, and it'll eat the entire screws. We've seen many windows a few years down the road where there's nothing left of the screws holding them in. So hurricane shutters are fine maybe if you have a Cat 1 or Cat 2 hurricane. So as long as you can guarantee that you're not going to have any more than about a Cat 3, they may be okay. But almost all hurricane shutters are only rated to 140 miles an hour. And Irma actually was 70% above that rating, which is why almost all hurricane shutters failed in St. Martin and other places. But not only are they not rated for the highest winds, but very often they're put on an oversized relative to their specified maximum dimensions. And the other problem is wind load can sometimes deflect the shutters sufficiently to pull them out of the rails, or they could have fastener failure. So hurricane shutters, I'm afraid, are more of a liability than they are an asset. And that was proven over and over again. One of the things in St. Martin, we had a building that had all of the high impact hurricane resistant windows installed. And then the owner decided he was going to protect them with hurricane shutters. We came along after the hurricane, and sure enough, the ones that were not protected were cracked. They had missile strikes, about 2/3 of them. But then the windows with shutters on were completely gone. The shutter hammered the glass out. Eventually the glass disappeared, the shutter disappeared. The wind came in and destroyed the building, which wouldn't have happened had it not been for the shutters. So there are three basics to windows and doors. And so if you're going to buy them and you're not really sure, check these three things out at least. First of all, are the frames, mullions, etc., strong enough to stand up to the highest wind speeds? That means that they should have a wind load test to it. And I'll talk about the level that you need these days. The second thing is the glazing needs to be capable of surviving multiple missile strikes. So it requires a very strong laminate. There are some laminate available locally throughout the Caribbean, but 95% of them are too thin to stand up to any kind of impacts. The last thing is that the glazing needs to be secured to the frame, because otherwise, if it's not, then when it gets hit and becomes flexible, it'll simply pop out. So rubber gasketed windows don't do it. What you need to do is to glue the glass into the frame with a strong waterproof adhesive. Now, it was mentioned earlier, Jamal mentioned that installation is critical. First of all, your fasteners need to be able to retain their strength for the life of the building, which requires high-grade stainless steel and preferably coated to be impervious to salt air. We coat ours with Cylon. You put them in a pail of salt water, leave them there for a year and take them out and they will see no deterioration. The other thing is the fasteners need to go all around the perimeter at intervals sufficient to transfer wind load. Our spec is not more than 4 inches from each corner and no more than 16 inches between screws. The fasteners must be sufficiently strong so that they don't pull out and bend or pop out when under wind load. That's why we use 3-inch long screws, at least 1 inch of which needs to be into an opening that's not much bigger than the screw, so it'll bridge against the side, and also using 100% silicone caulking. So after 15 years in the business now as an engineer and manufacturing, testing, and then also observing different products in real life experiences, we have now developed 2 product lines. One of the things is that the high impact hurricane windows are extremely expensive. They can be 2 to 4 times the cost of a regular window, and that prices it pretty much out of the market. But we found that our least expensive window with a laminate glass that we use, a security laminate glass, actually performed almost as well in Hurricane Irma in St. Martin as the high impact one. So we've now come up with an economical hurricane line that everybody can afford. It's an increment over the regular windows, but everyone can certainly cover it. So in terms of the wind load standard, mentioned before that the wind load from the most intense hurricanes are more than 4 times that of a Cat 1. Shutters can't stand up to these wind loads, and they'll fail almost completely in intense hurricanes. So with more intense hurricanes now becoming normal, we have adopted the same wind load standard for both the economical and high impact product lines, which is 200 miles an hour, which you'll remember is 10 miles per hour higher than the strongest ever Caribbean hurricane. So to test for wind load, you put it against a test wall. This is our test lab. You then put it in a buck, seal it up around it. Then you extract air. And so we can actually test up to 250 miles per hour equivalent. And this shows what happens when wind load is excessive. Now, this is the inexpensive window that did so well in St. Martin during Irma. We took it to a lab that didn't have our test lab done. This was in the US in West Palm Beach, and it failed at 264 miles per hour. So clearly that was it's a very strong little window. The next thing is the quantifying the impact. And there are 2 impact standards. For our economical hurricane line, we use 3 blows of a ASTM-E 1996 Missile C, which is a 4-foot-long 2x4 fired from a cannon at 40 feet per second. So this again is the test of that same window. So you'll see the window is very damaged, but it's only the glass. That can all be replaced. But the point is the hurricane would be on the outside. Now, that is the lowest, that's our economical one. But still, as you can see, there's a very good thump from that Missile C. The high impact products are tested with Missile D, which is twice the length and fired from a cannon at more than the speed of the Earth. Now you see this is a large unit, and a lot of people would think the bigger the window, the more vulnerable it is. It is more vulnerable from a wind load because the area is larger, but actually from impact, the larger the window, the more the laminate has time to stretch and absorb the impacts. Now this is an example of kind of what it looks like from human intervention.
I think you need a bigger hammer. Try again. You're not getting in very well.
So this shows that the strength of the laminate and the high impact also provides very good security, but that is overkill for a number of people. If you can't afford anything, at least get the protection from the wind load, because that is probably the most damaging part of these intense hurricanes. Now, flooding, Jamal mentioned earlier, is also can be very highly destructive. So you need to find out, are you in an area where it has flooded? What about drainage? We talked about all of those sorts of things. If you are going to be in a relatively flat area, then you can protect yourself against flooding. Seal the exterior of the building to above historic levels. Install shut-off valves in the main sewage, otherwise you're going to get backflow. And then put in a flood-resistant door. Now, if the flood levels exceed 2 or 3 feet, that's typically the most common, then you're really going to have to work at it to make the house resilient. So this is one of our impact doors, a hurricane door. It also turns out that it also performs very, very well. It's perfectly dry, even with flooding. So as I said, most floods are only 12 to say 36 inches. It's best to be actually put up to. So if you protect from the hurricanes, you can also protect from flooding as well. So having spent 15 years in this business now in the Caribbean, and having traveled to most of the islands, dealt with governments, institutions, it's amazing how many individuals are still unaware of what causes building failure and how to prevent serious damage. Now, hurricane risk is real, and the consequences of a severe hurricane strike can take a life or have a lasting grave economic impact. So window and door failure is the leading cause of severe hurricane damage. Again, from these intense ones, it's wind load, wind load, wind load. And every homeowner could be protected. Everybody can afford the economical stuff. And if you want the premium, and go for that. So the last thing is just to, if all else fails, make sure you've at least got insurance, even as a renter. And so that's kind of the last line of defense. So I'm going to now open the floor to questions. And so maybe everyone can turn on their camera and see if we've got any questions.
Yes, Terry, good evening, everyone. So the first question, I believe, comes from Alicia Ramdeen. She asks, does Domus have impact windows? And if yes, can they stand up to a Cat 5 hurricane?
Yes, as I said, our standard is 200 miles an hour. We test to that. We generally test at 210 miles an hour, but we'll guarantee 200 miles an hour. So yes, and they're not that expensive either if you go for the economical ones.
I have another question. What guarantees are there, if any, if I invest in hurricane rated windows and doors?
Well, we can guarantee that they will be intact and provide the same protection for indefinitely, for at least 20 years. Beyond that, I mean, we don't ever say hurricane proof. We say hurricane resistant, because if your neighbor's roof comes off and goes through the side of your house and takes out a window, you know, that can happen. But in terms of performing, not popping out up to 200, you know, the strongest hurricane we've ever had in terms of the wind load. And then, as I said, the impact as well, it'll take an awful lot of beating before it lets go. But again, if a truck or some metal object, a TV tower or something comes through the window, well, you know, you can only go so far. But they will stand up. In most cases, we have had very little damage, even in Irma, under the worst conditions.
If I may.
Yeah, Jamal.
Yeah, go ahead, Jamal.
Yeah, so to respond to that question, I would say that a strong category 5, like Maria and Irma, will almost always do some sort of damage, right? Hurricane impact windows, properly installed, should stand up to the wind loads. Again, as Terry said, something may happen, another part of your house may fail, but what you can, the guarantee you have is that if you have a strong category 5 and you do not have impact windows, I can guarantee you will lose those windows and you will lose your roof. You understand? So I think that is the guarantee that you can look at. That I mean, no one. After Hurricane Maria hit Dominica, talk started circulating about trying to have a Category 6, grading for hurricanes, because the difference between some of these hurricanes and a Category 4, a Category 4 is so drastic that some of them are above what you would consider a Category 5.
I agree. You should do that.
Yeah. So again, the guarantee, as far as I'm concerned, is that if you do not have impact windows and your windows are not properly installed, you will lose them. If you have impact windows properly installed, you have a very good chance of coming out of that storm in one piece.
Correct. Yeah, maybe no guarantees, but 90 over 90% anyway in most cases.
Thank you for that, Jamal. Another question here is, are Domus's hurricane products available in St. Lucia?
Well, yes, we'll ship within CARICOM or duty free within CARICOM, and we will ship to them. We're looking for a local distributor right now, as we have in many of the other islands, but we can ship to St. Lucia right now. We've done a number of projects in St. Lucia. For instance, the regional center for courts has our windows in both interior and on the front facade. So, yep, they're available.
Are there currently any companies that in St. Lucia that provide secured roofing, Jamal? I guess this would go to you, Jamal.
That provides secure roofing?
Yeah, that constructs a roof to code and standard. Basically, I think that's what the gist of this question, yeah.
Well, it wouldn't really be a company. A roof is a collection of elements that's built up. So whether you have a concrete roof or a timber roof, it's a collection of elements. You have your rafters, you have your purlins on top of that, you have your screws, your roof covering. We have 2 companies on island at least that manufacture and provide the roof covering. We have many companies that provide the material. It's about selecting the proper material. It's about the roof being designed properly, and it's about it being constructed properly. So if you're talking about having a properly installed roof, again, have a proper design done by a professional, ensure that proper materials are bought by the contractor. Your professional can oversee that as well, the selection of the material, the specifications by your designer. A full architectural and engineering design will specify the strength of material. It will specify the strength of the concrete to be used in your house, on your concrete roof, etc. It will specify a sealant for the concrete. Proper specs will specify what screws to be used on the roofing, the gauge of roofing to be used on your house. So all of this information should come in a full set of architectural drawings or engineering drawings. And once it is designed properly and built properly, you have a proper roof. But it's not one element that you can say that a company will sell.
Well, I would say one piece of advice: do not rely on the contractor. Involve a professional, somebody like Jamal or other people who can be a third party, and both with speccing the materials, inspecting while it's being constructed. Because I hate to say that the vast majority of contractors throughout the Caribbean are not up to snuff when it comes to roofs.
And I will also say that I wouldn't say that all contractors do that. I know some contractors who pay close attention to the drawings and to what's being done. But it's important again to just have a professional involved and listen to your professional. You find a lot of the time you have a professional involved, they give you some advice or they try to hold the contractor to task. And what happens a lot of the time is the contractor will tell the client, he's just making it more expensive for you, you know, or you don't know what you're talking about. You know, I've been doing this for 20 years or 50 years. Yeah, they may be doing it for 50 years, but they may have been making the same mistake for 50 years. Remember, St. Lucia hasn't had a strong hurricane in a while. Hurricane Thomas was barely a category 1. Don't think that you survived Hurricane Thomas so you can survive a hurricane. Thomas was barely a hurricane. I think it became a hurricane just before it hit us. Before that was a tropical storm, you know?
Yeah, well, I guess
Thank you.
I think St. Lucia is probably better regulated than most of the islands. I would certainly say that, but I have been appalled.
Oh. Terry, this one came in for flood resistant doors. Are these currently available?
Yes, that's their standard hurricane door. And we decided to test it for hydraulics as well. They stay completely watertight up to about 3 feet. Once you get up to the door itself will stand up to much more than that, but water starts coming in through the locks when it gets past 3 feet. So.
Okay, and does the windows and doors aid also like in sound reduction? Somebody had seen a post, it seems, so they want to know if it does aid in sound reduction during a hurricane, as it's very loud sometimes from the flying debris, etc.
Yes, I've heard that. I haven't actually been through more than a Cat 1 myself, but I hear that as it cranks up that the whining, Angela might be able to speak to that. But as I understand it, there's a lot of trauma from the noise. Sounds like a freight train keeps going through your house. And you could, if you saw the prelude to the webinar, you'll see that all of our laminate doors, all of the hurricane windows and doors are sound resistant. They're not totally soundproof, but a dramatic reduction in noise.
Yeah, that is certainly true. I'm reflecting now as you're speaking about several stories in the Oma diaries where people talk about the horrific sounds and that being one of the things that haunts them and continues to be a traumatic experience even after the event. So it's good to know that the windows serve that function as well.
If I may chime in here as well, keep in mind that although your windows and doors may be sound resistant, roofing and the ceiling is important. If you have exposed rafters with boarding under it, you will have a lot of sound coming through that. And coming out of a lot of experiences I heard from friends and colleagues in Dominica, I mean, people spoke about the hurricane sounding like a lion roaring, you know, all through the night and that sort of thing. And I saw grown men tear up every time they start to speak about the storm. You know, big hardback men tearing up, you know, just because it was so terrifying. And a lot of them told me that for weeks after that hurricane, every time it rained, even if it was a drizzle, the children would start to cry, you know, because they were so traumatized by it. So the sound definitely has a lot to do with it. So having an insulated ceiling on the roof will help you. Having insulated windows and doors, that sort of thing will help as well with that.
Thank you so much. Angela, someone is asking how they could purchase the Uma diaries actually, because this person is not from St. Lucia.
Okay, well, there are two options. If you would like to get a hard copy of the Oma Diaries, you'd have to go to the website for the book, which is theomadiaries.com, and those will be shipped to you wherever you are in the region or otherwise. If you are interested in getting an electronic copy, though, you can just go to amazon.com and purchase it
It's on
Amazon.
Amazon.
Yeah.
Lovely.
That's where I
Lovely.
got mine. Amazon.
Thanks. So we can assume, someone asked if the building codes are enforced in St. Lucia, and based on what you guys have explained, Jamal, I believe, yes, they in a lot of instances they are, because your contractors tend to do things responsibly. Yes.
I wouldn't say that.
I was hoping.
And I wouldn't
right.
say that. Maybe I
The,
should do that.
yeah, the regulatory framework in St. Lucia.
Whoops.
So that you're freezing.
Emmanuel is for, he probably dropped out.
Well, I think this internet must have left.
It seems so. So since he's frozen or something, let me jump in there. The codes are available. They are available for persons to purchase. They are available for contractors to purchase, designers, etc. And most designers, most professionals I know would design according to it and would try to ensure that houses are built. I don't know many contractors who have a copy of the code. I know a couple who do, but not that many. Most contractors design according to basically what you consider best practice. And best practice is selective, so not everyone knows best practice. That's why the Institute of Architects, we had actually had a workshop last year trying to promote actual best practice. Some of the slides I used tonight were from that. So we tried to promote what should actually be done. We tied it in a lot with what's suggested in the code. But again, code is really suggestion. Until you have enforcement by the authorities, it's really a suggestion. So it's up to the client, the contractor, and the professional to ensure that your house is designed and built according to code.
As I understand it, you actually have inspections there during construction. In Trinidad, there is no such thing.
Well, we have it on books, on paper.
Oh.
And truly, the manpower is not in place. The building inspectors are really underwater with what the amount of work that they have to do. So they tend to visit the sites in the initial stages and once or twice in between, but it's not as thorough as it should be, to be honest. Let's see. Go back in.
Yes, as I was saying, the implementation is through the Physical Planning Act, and as we've indicated here, there is a need to use professionals. Why? Because the requirements of the building code are minimum requirements, and that they do not substitute for sound engineering and architectural practice. And so many persons use the code or refer to the code as if it were a ceiling. The building code is a floor. Everything it builds on top of it. And so if we understand what the code is there to do, it sets the minimum bar for health and safety. And it also, in terms of construction and construction practice, it also sets the minimum cost of construction in the context. So you cannot violate the code. You must be code compliant, but mere code compliance is not a replacement for sound engineering or architectural practice.
Thank you so much, Mr. Emmanuel, for that contribution. I do not see any more questions in the chat. Yes, I do believe that we have gone over quite a bit in terms of the time. So do you have any closing remarks, Terry? Our audience is still here. Thank you so much, audience, for sticking with us, even though we went over.
Hang on 1 second. Terry, I do see a question there that I'm not sure that you addressed. Someone had asked if your windows and doors come with the hurricane rated installation.
Rated installation. Sorry about that. I missed that one. Yes.
With the what?
With the hurricane rated installation materials, the screws, etc. They wanted to know.
Yes, we have all of that automated. So whenever we have a particular order, we can push a button and it will tell us exactly how many screws, how many washers, how much silicone, all of those sorts of things. And those are available directly from us.
No, I think what they wanted to know was, is it included with the window? So once you push the window, does it come with all of that?
No, it's a separate charge. Because otherwise, when people are comparing, very often they'll compare a window with no fastenings to ours. So we quote on every single one, but you know, it's all available. It's not that huge amount of money, but it's very well worth getting the proper stuff, proper stainless steel and neoprene seals and so on and so forth.
Okay, thank you, Terry. Yes, I do believe that that was the final question. We do thank all the attendees this evening for tuning in, and we do thank our panelists. You have any closing remarks, Terry?
No, I just wanted to thank the other panelists for participating. And I think all of us in the kind of in the industry have a responsibility to our communities and to the region to try to bring people up to speed on the practicalities. That's why we wanted to try and keep it very practical, down to earth. And all of the co-panelists did a great job on that. And I like the way Angela in particular described the terror and a lot of the practicalities, because St. Lucia has not seen a hurricane for a while. And I just worry about what might happen when if something like Irma was to hit. So thanks, everybody.
Thank you. Thank you for having us.
Good night, everyone.
Just to reiterate, if you do need a copy of this webinar, you can reach out to us via email at feedback@domuswindows.com. I'll put it in the chat here. All right, you could send us your request.
And I mean, we'll make that available to the other panelists as well. And so they can also approach any of the panelists.
Yeah, so I think what we will do when we get it, we will upload it to our Facebook page, our YouTube page, etc. So persons can view it afterward as well.
Great. So thanks again. Unless you have anything, Ayana, good night, everyone. And nice to work with you.
All right, good night. Thanks, everyone.
Good night, everyone.